In this video, we're going to look at the Riparian Denitrification Practice tool. This tool determines suitable areas for saturated buffers along the riparian analysis polygons. It also suggests areas that may be suitable with some carbon enhancement, typically introduced by wood chips. Saturated buffers work by building a lateral distribution line, usually of perforated pipe, along the riparian buffer and also a diversion gate that intercepts tile drainage. The diversion gate can be raised, and then this will in turn raise the water table within the buffer, saturating the area. And this enhances nutrient removal from the tile water. So first, let's take a look at the tool interface to get an idea of what it's going to be asking for. The first input is the stream reach. This will be the same one you use to create your riparian catchments. We'll input the actual riparian catchments, our unfilled DEM. This is the new DEM. Your Z factor. We're also going to include the slope raster, our G-Sergo raster, the soil profile table, and then a crop data layer. You can choose to use any year that is provided, though if you're looking for most recent, you may want to run the get NAS tool and use the most recent CDL raster. We then need to set a minimum organic matter percentage, a maximum percentage of coarse soils, a minimum percent of near stream soils in which all soil conditions have been met, and a minimum percent of riparian zone that must consist of slopes between 2 and 8%, and then set a maximum bank height. All of these last inputs are going to be based within at least that 90-meter riparian zone. And our output is going to be the saturated buffer table, which, similar to the riparian function table, will be able to be joined to the riparian catchments or riparian attribute polygon output. I'm going to go ahead and populate these fields and let it run. So it's looking for that new DEM. Bring that in, our Z factor of 0.01. And then we have to go and select a CDL raster. I'm going to use 2017, most recent. I'm going to keep these all as the default. And then our output is going to the correct place, the saturated buffer table. I'll hit OK, let it run. So the first step is to create our units of analyses, and this is going to be the 90-meter buffer around the stream reach. Again, extra processes are done to make sure that none of these buffers overlap one another. The next step is to look at soil conditions within these 90-meter buffers. The following soil conditions must occupy 35% of the area within 20 meters of the stream. The user can vary this percentage from 25 to 75%. The soil criteria defaults are as follows: that organic matter must make up at least 1.5%, and that is from the surface to 1 meter depth. The max coarse material must be less than 65% from 50 to 150 centimeters depth. And the drainage class must not be well drained. The next criteria is bank height, and bank height must not exceed 12 feet in height. This is tested by finding elevations above the stream within 20 meters of the channel. This is done to ensure stability if the area becomes completely saturated. The next criteria is slopes. 35% of the area in each 90-meter riparian zone must be between 2 and 8%. And finally, agricultural land must exist within the buffer zone. Alright, so the tool is finished running. Let's take a look at our attribute table. The unique ID here is the riparian ID. So we will be able to join it to our riparian catchments and riparian attribute polygon later for symbolizing. There's the straight line length of the stream segment associated with each riparian catchment, the acreage of the riparian catchment. We have the dominant drainage classification, the bank height in centimeters, the percent of area that meets all soil conditions, the mean organic matter of the dominant map unit, the max coarse material percentage of the dominant map unit. We have the percent of cropland within the 90-meter riparian zone, percent of pasture within that zone, and percent of forest, and the percent of non-agricultural land within that 90-meter riparian zone. And then we have the percent that occupies 2 to 8% slopes within the riparian zone. And finally, we have if it is suitable for saturated buffers. This result can be yes or no, or yes with carbon enhancement, and that would indicate that things such as wood chips would need to be added to the saturated buffer. And then we also have the reason for failure if it did. You see, if it was suitable, the reason will just say suitable for saturated buffers. So now let's go in and symbolize. So I'll go to my riparian catchments. I'm going to remove the join that I had previously added for the riparian function table. You don't have to do this. I'm just doing it to simplify the attribute table. So I'll go in here, join, select my saturated buffer table, make sure the join is done based on the riparian ID, and hit OK. Then we can go into symbology, go to categories, and let's symbolize by saturated buffer suitability. Again, our headwaters are null. We can make no red, and we'll do yes as yellow. Hit apply, OK. And we can see that we have quite a few suitable sites along here that would be good for saturated buffers. We can also join this table to the riparian attribute polygons. Hit OK. And then, similar to before, in symbology, we can simply import from riparian catchments. Hit OK. We want to import the symbology from the saturated buffer suitability, so hit OK. And there we go. Hit apply. Alright, so now our riparian attribute polygons are also symbolized the same way as our riparian catchments. And now, using the identify tool, we can select some of these larger riparian catchments that are shown to be suitable. I just clicked on this large one here. If I expand it, I can see the riparian attribute polygon that it's associated with. And clicking back on the riparian catchment, I can go down and look at how many acres within this riparian catchment are actually likely to be tile drained. Remember, saturated buffers rely on having a tiled system already. So out of these 700 acres, 91 acres are likely to be tile drained already. So this may be a good place to start looking for suitable sites and approaching people about saturated buffers. Here's a brief recap of the denitrifying practices tool.